Hey guys, welcome to this session by Intellipaat. In this session, I want to look into Maven. So we're going to comprehensively learn everything about Maven and also have a hands-on at the end of this session. And before moving on to the session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. Now, before moving on, let's take a quick glance at the agenda. So we'll start off with what is Maven and why do we need Maven. Once that is done, we'll look into what does Maven do. That basically means it's working and what can you use it for. After that, we'll learn about the POM file. Once that is done, we'll move on to some Maven concepts like Maven lifecycle and Maven repositories. Once we learn all these theory concepts, finally we'll understand how to install Maven, that is basically installation of Maven. And once we do that, finally we'll move on to the Maven hands-on demo, and that would be the last part of this particular session. So now, without any further ado, let's begin with it.
Before we know what Maven is, we need to know why do we even need to learn about Maven in the first place. Now imagine that you work for a small company and they have tasked you to create an app for them. This company acts as a mediator between restaurants and customers. It's basically a food delivery app that you have to make. How will you plan to build the app? You would look at the requirements and then decide what kind of features it will have, right? Since it's a food delivery app, we'll need a basket, we'll need a payments option, we'll need a support option, we'll need an account settings option, we'll need a search options. Now that you have decided what will be needed in your app, you will move forward to see what kind of structure you will use to build this app. You can go two ways with this. You can either have a single build code or you can have multiple modules for the app. It's easy to go back and check for any bugs or errors if they can be easily located, but inside a singular build code file, it would be difficult to do the same. It's much easier to add and handle features if they divide it up into smaller multiple modules. Now, having multiple modules is great and all, but it comes with its own problems. Since we have so many modules, like thousands of features in each module, we will have to go and execute each module one by one, and that will take a lot of time. Then we have to see which all dependencies each module will require. You will need to keep track of all the dependencies all the modules will require. And to download each of those dependencies, you will need to go online and download them manually. This will also take a lot of time. You will also need to keep track of which files call which. A module may be dependent on a previous module, so you will need to know about those kind of metadata too. To solve all these issues, we will use Maven. Since Maven is a build tool, it can help in building an application that has several different modules. It helps doing so by downloading dependencies. Instead of us doing it manually, what Maven does is it scans the project and sees which all requirements or dependencies are needed, and it then goes online and downloads them for us, and then it manages them also. It also enforces a directory structure. Now, in an organization, data needs to be organized. After you're done working on the project, someone else needs to work on it too. So for that purpose, it will enforce a clean directory structure where only specified things will be stored in specified folders, and ultimately it helps in maintaining the application. Now that we know why we need Maven, we can move on to what Maven actually is. Maven is commonly referred to as a build tool. It is used to manage the entire life cycle of a project, generate reports, and store documents with its POM repository. It's a successor to an older tool called Apache Ant tool, which was developed in the 1990s to do the same thing. But it's old and obsolete now. People use Maven in the industry because it's a lot more automated and it's a lot more standardized. Also, it's mostly used for Java-based applications. So what Maven basically does is it takes all the modules and scans through them. It scans them for dependencies and requirements. It then goes online and downloads those dependencies and then injects them into the project. And after it's done doing that, it takes all the modules and then compiles them or builds them into a single executable file. This file is then reviewed and then rigorously tested. And after it's been successfully reviewed and rigorously tested, it can be deployed as the application. What does Maven do? It enforces a directory structure and manages and downloads project dependencies, enforcing directory structure. For Maven to work properly, a standard directory structure needs to be created and be used for storing all the code and its related resources. Every folder has its own reason for existence. As we can see that inside the project home, there are three things: src, target, and pom.xml file. And all these folders serve their own purpose. Inside src, the main folder stores all the source code for the application logic. And then inside the Java folder, all the transactional code is stored. Inside the resources folder, all the text files that are needed by a code are stored, like the .cfg file or the .xml file. And the test folder stores all the unit test case code. And beyond this, all organizations have their own folders for their own purposes. Managing and downloading project dependencies. Projects may need Java APIs or frameworks which are packaged in their own jar files. These jar files are needed in class path when a project code is compiled. Now here we can see that a project contains a pom.xml file inside the directory. Now all the configurations that we need to make to configure Maven are stored in the pom.xml file. So what happens is that Maven reads through the pom.xml file and sees which all dependencies are needed. And then Maven pulls those dependencies from internet. And then after it's done pulling them, it stores them in a local repository and puts them back into the directory. Now there are two types of dependencies: external dependencies and snapshot dependencies. External dependencies are those dependencies that do not have any prerequisite. They're totally independent and do not require the help of any other dependency. Snapshot dependencies are those dependencies that may have a requirement of another dependency. By setting a snapshot dependency of a build, for example, build B on another build A's sources, you can ensure that build B will only start only after the one it depends on, that is build A, is run and finished. We call build A a dependency build, whereas build B is a dependent build. Building POM files. Every Maven project needs a POM file. These files contain all the details that are necessary for Maven to effectively execute a project. The POM file is stored in src or the root directory. As you can see, pom.xml files are very important to configure Maven. If they are not present, a Maven will not be able to build a project. These are written by developers to make sure that all the requirements that their code might need is told to Maven. As you can see, pom.xml files are very important. They are needed to configure the Maven. If there is no pom.xml file present, Maven will not be able to build the project. These are written by developers based on their needs. Now that we've seen what Maven is and what it does, let's see how it does things. Maven lifecycle. Maven is used to manage the entire lifecycle of a project. It generates reports, stores documents with its POM repository. When a Maven builds a software, it follows a build cycle. They are of three types: default lifecycle, clean lifecycle, and site lifecycle. We will concentrate on the default lifecycle as it's the most important one and is the one that's used most in the industry. Inside default lifecycles, there are 8 phases. There's the compile phase, there's the test compile phase, there's the test phase, there's the package phase, there's the integration test phase, there's a verify phase, there's the install phase, and there's the deploy phase. Let's start with compile phase. During the compile phase, Maven will compile all the .java files present in the main directory into .class files and put them back into the main directory in the dedicated folder. What this basically means is that it will take all the source files, all the code that has been written by the developers, and convert it into bytecode. When a person writes a code, he writes it in a language that a human can understand. But computers can't understand this language, and I'm pretty sure you know about this. What Maven will do over here is, it will take all the .java files that are the source files, and then it will convert them or compile them so that they become byte files, or here .class files, and then store it back into the directory in their dedicated folder. Byte files are basically binary code, which can be easily be understood by the computer. So what is Maven is doing basically is turning handwritten code into machine code, which can then be executed later. Moving on to the next phase, the test compile phase. During the test compile phase, Maven will take all the .java test files in the main directory and compile them into the .class files that will be then stored back in the main directory in the dedicated folder. Like I said before, what basically happens is Maven takes the .java files, in this case the test files, and then compiles them so that they can be converted from a language that is written in that can be understood by humans into language that can be understood by machines or bytecode, and they are called .class files here.
Okay guys, a quick info, if you're looking for an end-to-end training in DevOps, Intellipaat provides that, and you can check those details in the description box below. Now let's continue with this session.
And then stores them back into the dedicated folder. The next phase is the test phase. During the test phase, Maven will execute the specified test cases and create a summary log. What happens during this phase is that Maven will take test cases and run them on the source code. This will create a summary of how the test cases performed, which will be stored in the directory too. Package phase. During the package phase, Maven will package all the .class files and resources into one file. This file will be formatted into one of the three types below, either a jar archive or a war archive or an EAR archive, depending on the type of application that is being built. So what basically happens in this phase is that all the bytecode that has been compiled in the previous phases is now packaged by Maven into a single file that can either be a jar file, a war file, or an EAR file, depending on what kind of configuration that has been written in the pom.xml file. Here, jar files are used as a Java archive, which are not commonly seen in enterprises. The war file is used as a web archive. It is used, but not as commonly as the EAR files. Now, the EAR files are enterprise archives, which are commonly used and given to the middleware team and are much more complex than the other archives. Now, one thing important to note over here is that all these phases are executed simultaneously. Whichever phase you invoke, the process involves the execution of all the phases till the one you have selected. Maven will always start from phase 1. For example, if you want to package your project, it will start from phase 1. It will first compile the project, then it will test compile all the test cases, then it will run all the test cases and create a summary report, and then it will invoke the package phase and package the project into one singular file. Moving on to the next life cycles. Now, compared to the default life cycles, the next two life cycles aren't that important. The clean life cycle. Now, this life cycle has three phases in total. It has pre-clean phase, clean phase, and post-clean phase. In this life cycle, all the files that were produced by Maven will be automatically removed. What this means is that in the previous build, whatever files that were produced, like the .class files or the test files or the summary reports or whatever was produced as a result of Maven compiling and packaging the project, will now be removed using this life cycle, that is the clean life cycle. Site life cycle. This life cycle has four phases in total: the pre-site phase, the site phase, the post-site phase, and the deploy site phase. The site life cycle generates a project file documentation in the HTML format, but this cycle is usually ignored as its output is not that useful. It creates a report by understanding the dependencies, but the output is nowhere useful, so it's not often used in organizations. Maven plugins. Plugin is a file that contains the knowledge for what is supposed to happen when a phase is executed. For example, if you wanted to execute the clean phase, then the knowledge for what is to happen in the clean phase is contained in the clean plugin. And the goal is clean. The goal is achieved when the phase is executed successfully. If the clean phase is executed successfully, then the goal is clean. Another example would be if you wanted to use the deploy phase, then the information for what is to happen in that phase will be contained in the deploy plugin, and the goal would be deploy. Maven Repositories. After Maven understands which all dependencies are needed from the pom.xml file, it will download them from where it needs to online and then store them in the local repository for current or future use. What this means is that when you write the source code, you require some dependencies, and when you need to build it, you will mention those dependencies in your pom.xml file. So when Maven goes through the pom.xml file, it knows which all dependencies are needed. It then accesses remote repositories to download those dependencies, and then it stores them in a local repository for either current use or future use. Now, once a dependency has been downloaded through Maven, it will be stored in a local repository so that when we work on a future build, we have easy access to the same dependency. We do not need to access the remote repository again. This increases the availability of the dependency, and it also increases the efficiency of the building of the project. Now, there are three types of repository that Maven uses: local repository, central repository, and remote repository. Local repository is the repository that is stored in the developer's system. Central repository is the repository that is maintained by the Maven community. And remote repository is the type of repository which is used by companies to maintain integral projects. Now that we learned everything about Maven, what Maven is, why do we need to use Maven, and how does it work, we will have some hands-on practice for Maven. But before that, let's install Maven. To install Maven, we will first spin up an instance in AWS. We will be using the Red Hat Enterprise Linux version, CentOS. Click on Review and Launch. Click on the pair of keys you have. Click on I acknowledge, launch instances, view instances. We will be waiting for it to get initialized. We will copy the IP address. We will open our putty tool, paste the IP address, go under connections, SSH, authority, browse and put our key in, and then we'll open. We'll click on yes, and we'll log in as EC2 user. Let's make it a little more clear for you guys. It's full screen. Change the color to green. Apply it and we'll clear the screen. So let's see what the next step installing Maven is. Java is a dependency for Maven. Okay, before we install Maven, we will need to install Java, as Java is a requirement for Maven. So let's install Java. Yum install Java. So we will install Java with this command: sudo yum install java 1.8.0 open jdk devel. Press enter. Yes, please. Wait for it downloading and installing Java. Now we'll check if Java is installed or not. For that, we will need to use yum install Java. Yum list install Java. Alright, now we can see that Java has been installed properly. Let's go to the next step. The next step is get the latest version of Apache directly from their website. Okay, let's head to the website. Apache Maven. The thing is, we will not be using the package installer to install Maven, because sometimes what happens is package installers only have the old version and the new version hasn't been updated. So to get the latest version of a particular software, we can always go to the website and download the version directly. So we'll go to Apache Maven website, click on download, scroll down, and we'll get this version, bin.tar.gz. Right click on it, copy the link address, and come over here. Let's clear the screen. We'll head to OPT. This is where we'll store our file, and we'll use the wget command to get the link. So since it's not installed, we'll install the wget command. Okay, now that wget command is installed, we will do the same thing again. Sudo wget and the link of Apache Maven. And let's clear the screen. ls to see whether it's installed or not. Yes, it is. Now we will use tar. We will untar this file, tarzx apache. We forgot to use sudo tar zxf apache and ls to see if it's untarred. Yes. Now let's just sudo su so we don't have to use sudo every time. Okay. The next step is to unzip the tar file and then go inside the unzip folder and then into the bin folder. We will cd into the Apache folder /bin. Alright, now we're inside the bin folder. The thing with Apache is, now that we've installed it, when you download it directly and unzip it, it comes pre-installed. You do not need to install Apache again. When you unzip it, that means it's installed already. But the thing is, it's only accessible from this point of the directory. We want to make Apache accessible to all over the system. So for that, we will need to use this command: export path equal to $path /opt/Apache Maven 3.6.2/bin. We are setting the environment variable so that the package can be accessed from all over the system. We are setting the environment variable, that is the path. Path here is the environment variable, and we're setting it in such a way that Apache can be accessible from all over the system. So it will be export path equal to $path /opt/Apache Maven 3.6.2/bin. Alright, now that we set the environment path, that we set the environment variable path, we can move ahead and use Apache Maven. First, let's just make sure we have installed it properly. Maven version. Yes, as you can see, Apache Maven 3.6.2 has been installed properly.
Okay guys, a quick info: if you're looking for an end-to-end training in DevOps, Intellipaat provides that, and you can check those details in the description box below. Okay guys, that's it for this session. I hope you understood and also it was helpful and informative. If you have any queries, leave a comment down below and we'll love to help you out. Thank you.